Hey everybody, what's going on? It's Marshall here with Spiral X, and today we've got a video for you all about fuel rings. If you're new to BTEX or it's a foreign topic for you, that's fine. We're going to go over everything in this video. So what I plan to cover today is fuel rings, where they're used and why they're used, the equipment that they're attached to, so that's going to be the fuel air mixer on the burner in the glycol regen. I'm going to go over how the fuel ring works with the mixer, how they work together, and how they affect each other. And then I'm also going to go over air-fuel ratios and how that correlates with emissions. Okay, so let's go ahead and jump right in here. First question: where is a fuel ring located on the process equipment? A fuel ring is usually located on a glycol regen skid. It's installed on the back side of the natural draft burner inside the fire tube of the glycol regen skid. What is the fuel ring's purpose? The fuel ring functions as an adapter which allows processed BTEX vapors coming from the BTEX system to be injected into the natural draft burner on the glycol regen skid. Ultimately, the fuel ring allows BTEX to be destroyed by means of utilizing it as a burner fuel for the glycol regenerator. Why does the fuel ring exist? Fuel rings naturally came onto the scene as a cost-effective way to destroy BTEX. They're affordable considering they require substantially less investment versus a remote burner like a combustor or an incinerator. What I have here is a cutaway diagram of a mixer head. The mixer head is the main component of the burner assembly inside the fire tube on the regen. The mixer head does exactly what it sounds like. It mixes the fuel and the air to be burned inside the fire tube. What I'm going to do now is briefly explain how the fuel and the air is mixed inside the mixer head. So right here, coming up the gas inlet, the gas travels up the body of the mixer head and into a metered orifice. The gas flow is actually regulated through this metered orifice by means of the needle assembly right here. The needle assembly can be tuned in and out by the operator to control the amount of gas that's flowing through the mixer head. On the back side of the mixer head is what's called the primary air shutter. The primary air shutter is responsible for regulating the amount of airflow passing through the mixer head body. Tuning the adjustment needle and the primary air shutter together is necessary in order to establish a stable flame. What I have here is a 3D model of the mixer head, and as you can see, we have the gas inlet and the main mixer body and the adjustment needle here. On the back side is where the air shutter would normally sit. This face is where the fuel ring is mounted. So as you can see here, this is the fuel ring. It mounts on the back side of the mixer head, and it has ports for the BTEX to be injected. The air shutter will now be pushed back, and it mounts on the back side of the fuel ring. So the fuel ring is simply an adapter that mounts on the back side of the mixer head that allows us to inject BTEX into the natural draft of the mixer. So we have BTEX gases that are being injected back into the burner of the glycol regen by means of a fuel ring. And what does this mean for the glycol regen, and how does the BTEX affect the burner inside the fire tube? Okay, on the screen I have several different fuel ring designs. Some are generic. Actually, the two on the top here are generic, and the two on the bottom are designs that we have come up with at Spiral X. So the reason why I'm comparing these two is because there's a dramatic difference in airflow between a generic fuel ring design and the Spiral X design. This is extremely important because fuel rings when they're attached to the back side of the burner, naturally pose themselves as a restriction for airflow. And this is particularly the case with a generic fuel ring design. Like you can see here, there is a large amount of material that is restricting airflow. And what that means for the burner inside the regen and the fire tube is a fuel-rich scenario. And what that means is, in talking in terms of an air-fuel ratio, we have a good amount more fuel than a standard stoichiometric air-fuel ratio, which means that the emissions are going to be higher and we're not going to get a very efficient burn. Even more so with the smaller diameter fuel ring, there is a great restriction here in airflow, which does not help with emissions and contributes to, once again, a fuel-rich scenario. With the Spiral X design, we have a large amount of material that has been removed, and the material remaining matches that of the mixer adapter, or I'm sorry, the mixer head itself. So this circular boss you see here with these tangent lines connecting to it, this matches the surface, the actual casting body of the mixer head. So this material right here is negligible in terms of how it impacts the airflow going through the mixer head. The same thing with the larger diameter body. This one happens to be for a 3-inch mixer. We have removed a substantial amount of material to greatly improve airflow. And what I'd like to do now is actually show this on the mixer adapter itself, or the mixer head itself. Okay, so here I have a generic fuel ring on the mixer head assembly, and I've actually color coded this fuel ring and the faces on it so that you can see the areas that are flowing air and the areas that are restricting airflow. So what I'm going to do is turn on a section view here so it's easier for you to see. And in the red is all the areas that are restricting airflow, and the green is where the air is able to flow through the fuel ring itself. So as you can see here, there's quite a bit of material that is restricting airflow. We have a decent amount of air that's able to flow through here in these green sections. But as you can see, the mixer body itself has this large cavity where there's no support for the fuel ring. So we have all this area here where we could use this to improve the fuel ring design, and that's what we wanted to try to improve on with our design. So I'm going to switch over here and show you the Spiral X design and how that's different. So you can see here we chose to go ahead and remove all this material and utilize this space to structure the fuel ring around. And what that allows us to do is greatly improve airflow and still maintain the same amount of rigidity. So I'm going to show the section view once again, and we will switch over to the contrasted view. So now you can see with the Spiral X design, we have greatly improved airflow, and we have just a very small amount of material that is restricting airflow. And we have actually done the surface area calculations and the cross-sectional area calculations, and Our largest, our mid-size fuel ring, the 3-inch, for the 3-inch mixer, is actually 40%. It has 40% more area than a generic fuel ring. And this drastically improves airflow. And what this allows you to do is get back to a stoichiometric and even a fuel lean scenario where you are burning all of the fuel and the BTEX that's passing through the burner. And you have an abundant supply of air, which allows you to actually run on the lean side of air-fuel ratios, which is good for emissions, including the hydrocarbon emissions and the NOx emissions. Because we can take the flame temperature down by running in a fuel lean scenario, we can reduce the NOx emissions. So this is just a great overall solution in terms of emissions and air-fuel ratios. Completely aside from the fact that it is far safer to run this fuel ring as compared to other generic fuel rings that run in a fuel-rich scenario. And I could show some pictures that will attest to that. Fuel rings that run in a fuel-rich scenario are dangerous, just to put it bluntly. There have been multiple fires when using these fuel rings. Dehi's burned down. It's just a bad deal. So if we go back to these fuel rings here, the smaller diameter fuel rings, it gets even worse when we go to the smaller diameter fuel rings, the 1.5 inch, for example. This is a generic fuel ring design you might see for a 1.5 inch mixer. We have improved our surface area and cross-sectional area from this design to our design, which improves by 68%, almost 70% more cross-sectional area to improve airflow and therefore reduce emissions. So the Spiral X fuel rings are just abundantly better than what's out there on the market right now. They're safer, and you're going to be able to reduce your emissions, your hydrocarbon emissions and your NOx emissions by using a Spiral X fuel ring.